viewers, welcome to CEC lectures. Myself Dr. Priti Jagwani from Department of Computer Science, Arabic College, University of Delhi. So in this present series of our computer networks, today's topic is network layer. So this is what we are going to do in a greater length of detail. Although we have seen the network layer along with all other layers of OSI model in brief, but today's and some upcoming lectures are totally dedicated for network layer and the various protocols which are being used onto network layer, the functionality of the network layer, how does it work, and so on and so forth. So network layer is our today's topic. Let us begin with this. Network layer, when I talk about it, basically if you can say it is the third layer from the bottom or the fifth layer from the top in our OSI model. Now, in brief, if we talk about, so data link layer is something which is present at the bottom of this network layer, and transport layer is something which is on top of it. So network layer is going to provide services to the transport layer. Now, one thing which is very important if we talk about network layer, that it is responsible for ensuring end-to-end packet delivery across multiple interconnected devices. So here the term which is important is end-to-end delivery. Basically, your network layer is concerned with getting packets from source all the way to the destination. Getting to the destinations may require making so many hops at all the intermediate nodes along the way, and that is kind of looking into that nuances or looking into that functionalities is actually the we can say responsibility of network layer. So when I am saying end to end delivery, this is the first layer which get into this end to end delivery. Before this, there was the data link layer which we have covered in detail in our previous lecture. So the functions of the data link layer clearly contrast with that of the network layer. So data link layer was having a very I can say a modest goal of just moving the frames from one end of the wire to the other. So network layer has become the lowest one which deals with end to end transmission. And when I am talking about end to end transmission, it must know about the topology of the communication subnets and choose the appropriate paths through it. So when I am saying choose the appropriate paths through it, so that means now here comes the concept of routing, that you need to select that which route is, or the network layer needs to select that which route is kind of is going to be the best or is going to be the optimized, whether it is the route number 1 or the route number 2 and whatever within the different routes. Also, your network layer must also take care to choose the routes to avoid the overloading some of the communication lines while leaving others idle. So that kind of we can say routing while looking into this kind of traffic overloading is also the task of your network layer. Finally, when the source and destinations are in the different networks, so that is also possible that source and destination belongs to two different networks. It is the responsibility of the network layer to deal with these differences and solve the problem that results from them. So basically, if we look into network layer, till now we have established the importance of this network layer in whole transmission, and this network layer is having its own place to fulfill in. But when as a designer of the network layer, we look into what are the issues which are going to be come up or which are going to come up while designing this network layer. So there are some design issues specified. What are those design issues? So when we look into the designing of network layer, we also need to look into whatever the services will be provided to the transport layer. Then routing of packets is another kind of we can say issue to deal with. Then we have congestion control also, and also a connection of multiple networks together. So, when we say multiple networks together, that means I am talking about internetworking, and this is the kind of scenario which I was talking about, that source is on the different network while your destination is on the different networks. So, when multiple networks are connected together for transmission, that internetworking thing is also a design issue. Now, here also I have listed down some of the design issues which are available with network layer. Please have a look. So, this is store and forward packet switching, then services provided to the transport layer, obviously that we have seen. Now, there comes a debate of implementation of connection less services as well as the implementation of connection oriented services. In our upcoming lectures, we will be definitely looking into this. And finally, there comes comparison of virtual circuit and datagram subnets. So, some of the issues, some of the problems we will be looking into this lecture, and some in our upcoming lectures. So, if we look into, or if we want to recall the position of network layer, let us see this with the help of a figure. This is on the third starting from bottom, and if we start from top, it comes at the fifth layer. The layer above it's transport, and the layer below is the data link layer. So, in this series we have also we looked into physical layer and the protocols and the functionalities of it. Similarly, data link layer also we have completed, and network layer is going to be our kind of this issue. Now, what are the responsibilities of network layer, which we have already covered in brief, but here we are going to kind of address them in detail. So, the first responsibility comes up as assigning the logical addresses. So, when I am saying logical addresses or assigning logical addresses or logical addressing, so network layer deals with assigning unique IP addresses to the devices for their identification across the network. So, here you can see on one side of figure we have rest of the internet or the internet which is available, then there is a router in between, and the kind of this functionality is implemented, and it is actually assigning unique IP addresses to all the devices. So, you can check it. There is a network address which is 205.16.137.32/38, and among this network address, so many whatever number of devices, here we can see 4. So, these 4 devices have been assigned unique IP addresses, and this is there to identify among the across the network. So, this IP address is going to be unique across the networks. So, assigning these logical addresses or assigning these IP addresses is actually the functionality which is taken care, which has been taken care at the your network layer. So, it also ensures accurate identification and communication across various networks. So, when we say logical addressing, I have told you process of assigning unique IP addresses. Earlier it was IPv4, and now presently it is IPv6. So, the difference between IPv4 and IPv6 is of bits. The IPv4 was kind of a smaller address, and now when the designers have realized, network designers have realized that the pool of IPv4 is actually kind of having the scarcity of the unique addresses, they shift to IPv6, which is IP version 6. Now, when we say logical addressing, we also talk about physical addressing. So, let me mention here that physical addressing is actually the MAC addressing, and logical addressing is related to IP addresses. Now, this logical addresses can be changed based on the network configuration, and please recall your MAC addresses are actually the physical, or we can say permanent, or the fixed address. But these addresses we can say are hierarchical in nature, and they help to identify both the network and the device within the network when we consider kind of both of the addresses. So, hierarchical addresses helps us to identify both the network and the device within that network. Now, why this logical addresses, logical addressing which is the functionality of network layer is important. So, first of all, it enables the communication between various devices on different network across the network, inter-networking communication if it is required, then it is it is enabled with the help of network layer, and also it facilitates routing by providing kind of location based information, in the sense that which particular device is kind of plugged onto or hooked onto which network. So, apart from this logical addressing, the next one which is in the kind of functionality list of networking network layer is packetizing. So, when I am saying packetizing, here is a figure to help you. Then here if you can see, it is having one traffic source, and on the other side it is having a receiver. On this in between this traffic source and the receiver, what you can see is kind of different routers. Now, keeping this figure in mind, let us try to understand what do we mean by packetizing. So, packetizing basically encapsulates the transport layer segments into packets, and this is essentially done for efficient transmission. Basically, we can say it is kind of an encapsulating the data which is received from the upper layers of the network. So, upper layer of the network is your kind of here it is the transport layer, and this data which is received from the upper layers of the network is also known as payload, and we are going to encapsulate that data in a network layer packet at the source, and at the receiving networking layer or at the network layer of the receiving device, this payload is actually decapsulated from the network layer packet at the destination, and this whole process which is encapsulating the data received from the upper layers and decapsulating the data received from at the network layer is also this whole process is known as packetizing. Now, in packetizing, if we look into detail, the source is going to add a header that contains the source and the destination address both, and some other relevant information which is required by this network layer, which is required by various network layer protocols, which we will be looking into our upcoming lectures. So, that relevant information which is required by network layer protocols to the payload received from the upper layer protocol, and then delivers the packet to the data link layer. So, basically at the source end, a header is being added to the payload. Payload is actually received from the kind of we can say top layers, and that header or that information contains source and destination address and some other relevant information. So, these pieces of information are actually we can say attached to the payload, and then it delivers the packet to the layer which is below it, which is the data link layer. Now, what happens at the receiving end? At the destination end, the network layer packet which is being received by the network layer from the data link layer. So, the communication goes like this. So, the transport layer is going to give it to the network layer, then network layer will in turn give it to the data link layer. After getting at the destination end, data link layer send it to the network layer. So, the destination host receives the network layer packet from its data link layer, decapsulates the packet and delivers the payload to the corresponding upper layer protocol. Whatever upper layer protocol is operating at the transport layer, that payload is being delivered to that corresponding upper layer protocol. The routers in the path are not allowed to change either the source or the destination address, and the routers in the path are not allowed to decapsulate the packets. Only the source and the destination layers, destination networks layer are allowed to do this. Routers in the path are not allowed to decapsulate the packets they are going to receive unless those packets are needed to be kind of fragmented. So, this was actually the whole process of packetizing. Now, moving further, the third and a very important function of network layer is host to host delivery. So, basically it is ensuring that data is reliably transmitted between two hosts across a network. So, here is a host A and then here is a host B, and there are networks between them, and in between the networks, across the networks or within a network, we have these devices which are routers, and host A, in between host A and host B, these routers are, we can say, kind of operating, and then because of this whole functionality, data is reliably sent or data is reliably transmitted between two hosts across a network. So, in this functionality, it is the job of the network layer to ensure that the data is transferred from the source to the destination across one or multiple networks. Now, this whole thing involves destination address, determining the destination address, then only your packet or then only your data will be delivered to the kind of, we can say, correct address. Also, it is to be ensured that data is transmitted without duplication or without corruption, and a fundamental aspect of communication in large scale interconnected systems like internet, that fundamental aspect is host to host delivery and is very important. Moving further, the next functionality of your network layer is related to forwarding. So, when I am saying forwarding, here we have a couple of terms. One is forwarding, then I am having flooding, then we have a term which is known as routing. So, we will be looking into all these terms. So, when I am saying forwarding, so that forwarding is actually forwarding means moving the packet through a router to the correct outgoing interface based on their destination. Now, what does it mean actually? So, from internet or one router is receiving a particular, we can say, packet. Now, which particular client, whether the client A or the client B, is the actual recipient of this packet or of this data, the data should be delivered to that particular we can say client. So, who is going to do this and how it is being done? So, on the basis of the destination address which is being encoded, or we can say which is being attached with the payload, on the basis of that destination address, these packets are moved through a router, and these packets are moved to the correct outgoing interface, whether it is going to B or whether it is going to A. That responsibility is of router to ensure that the packet should packet should be transmitted onto the correct interface, and this is actually the process of forwarding, transferring packet between network devices. And these network devices, here particularly I am talking about routers, and these are responsible for directing the packets towards their destination. And when a router receives a packet from one of its attached network, as it was shown in the figure, it needs to forward the packet to the another attached network, and this is more commonly known as unicast routing, or maybe to some of the attached networks. So, if the packet is being kind of forwarded to one network, it is unicast routing, and if it is being forwarded to more than one network, some of the attached networks, then in that situation it is known as multicast routing. So, whether it is multicast routing or unicast routing, router is basically responsible for this. So, when we say router has to do the functionality of routing, now within this functionality, or in order to implement this functionality, your router is going to use two things. One is routing tables. So, basically these are the tables which store the information about the possible paths to the different networks. We will be talking about these routing tables in detail as well. Apart from that, there has to be a forwarding decision. That means, based on the destination IP address in the packet header, forwarding ensures that the packet moves closer to their destination, and that too efficiently. Efficiently here means, we can say without getting corrupted, or without kind of having an error generated within it. So, the router uses, one is the routing table, another one is the forwarding decisions. And within this routing or in this process of routing, it determines the optimal path for the packets to travel across the multiple networks or within the single network, using so many routing algorithms and protocol which are standard and available. So, one term, as I mentioned here, apart from routing, which we kind of hear commonly at this particular stage, is flooding. So, that is also kind of a network routing technique. When a packet is forwarded to every outgoing link except the one it has arrived on. So, let us say it has arrived on the link A. So, except the link A, on all other links, let us say B, C, D and E, your packet is being kind of forwarded. This is known as flooding. So, flooding, as the name indicates, you just flood the whole network with the same data. Now, why do we need, I mean, at the one end we talk about optimality or something of those kinds of that sorts, but this flooding ensures a high reachability and can be used for some of the legitimate purposes like routing protocol updates. So, let us say there is a kind of protocol update, then that update has to be sent to all the nodes and kind of all the links, then kind of facility of flooding is used. But it is obviously, it has a downside. Downside says like generating duplicate packets and creating a vulnerability for denial of services DOS attacks is in DOS attacks, it is being the technique of flooding is being kind of, we can say, is utilized. Then if we want to look into the difference between routing and flooding, in routing we need a routing table. In flooding, as it is kind of as it is to be sent on to all other links except the one on which it has arrived, no routing table is required. Routing may give the shortest path, but flooding will always give the shortest path, because it will go on, your packet is going on all the paths, shortest, then medium, then longest, every path. Routing is kind of, we can say it is less reliable, while flooding is achieves more reliability. Traffic, obviously it is more in flooding as compared to routing, and in routing there is no kind of, we can say no possibility. No possibility is a hard term, I can say. So, I can say duplicate packets are not present, while in flooding duplicate packets are definitely going to be present. So, here in this lecture we looked into some of the functionalities of this network layer into detail, and we have also looked into what actually your network layer is, what are its prime responsibilities and what are the design issues. Here is a list of references for the preparation used for the preparation of lecture. I hope you have enjoyed this one. I will continue with the more functionalities of the network layer in my upcoming lecture. Till then, thank you. Goodbye.